to be a totally different story because now this is all covalent bonding. Ethanol is a poor nucleophile. Yeah, it entered the first column of our table. We do have a secondary, so this is going to go through SN1 and E1 because they are always going to be sharing the first step. Okay, so I will start with our leaving group leave. Once leaving group leave, I will form a secondary carbocation. However, there's a tertiary next to me, which I don't think my compound will be happy just with the secondary carbocation. Okay, my iodide, which I think is flowing around for teaching purpose, I still label them. Okay, now my hydrogen will do something called a hydride shift. And I'm forming a more stable carbocation. Okay, previously this was a positive and this is a hydrogen now. So I now form a tertiary carbocation. With me? Okay. That is here. Okay. Now the next thing is our nucleophile is going to attack on it. I will have ETOH. It can attack on top or from the bottom, okay? Or this is from the top or bottom. I don't want to mess it up. So there are two different scenarios, which will make this is going to be a pair. Okay. Okay, I'm doing the wedge one first. Okay, O, H, E, T. And keep in mind, you do not make our positive disappear. You just transfer the positive to oxygen because oxygen is the one who donates electrons. So once the oxygen donates electrons, there are two of them. So let me do the pink, two of the pink. They form the bond. Oxygen itself becomes positive. All right, and there are also, okay. There are also a scenario, as I can do this with dash. With me? Okay, the last step will be my iodide, which I think I will just copy paste. Okay. Well, take my hydrogen off. This step is called a deprotonation. Yeah. All right. So I'll have my since I was forming the lone pair by purple, okay, and my hydrogen iodide, hydrogen iodide, there's a purple bond. Okay, this is going to be SN1 product. Okay, all of those should be SN1. Let me write in blue. Did I use yellow in the class for SN1? Yes, okay, I'll be consistent with that. Okay, Just like before. Okay, by the way, the previous one I showed the major, minor. Both S1 should be major in this case. Okay, and then the same thing goes to E2. E2 will start the branches from the tertiary carbocation, which I will just copy this part. Okay, duplicate. Oh, okay. No, E1, my bad. Okay, this is going to be E1. I think I did blue for E1, right? Okay, this is S1. Okay, E1, the problem is I do have a tertiary carbocation. I want to form the more stable, which is Zaitsev. Okay, Zaitsev product means more substitute. With me? Okay, if I want to make the more substitute, okay, now I'm going to remove the hydrogen. We're just going to deal with this. There are 1, okay, orange, 2, and 3. That this 3 carbon is adjacent to my central carbon, which means theoretically okay, I can form double bond here, orange, double bond here, which should be the same as if I do the here, okay, right? Do I need to show the mechanism for this part, where you're all good? You're all good? Okay, if I'll show one in case it's needed by people. So there's a hydrogen, I'll only show the blue, okay? So the base is going to grab the hydrogen. Okay, with me? It works the same. So within the E1, we said we prefer more substituted. So the first one is 3 substituted. It will be the major, major, minor. Okay, so I'll just copy the major part. To my answer. Okay, so this is E1. If it's in the exam, you're going to write all of them. Are we cool with this?